Hi guys, this is just a quick homework video. Some of you have been asking some questions. I'm going to be looking at page 66, question 6, page 87, question 6, 7, 8, 9, 14, and then lastminute.com someone got in with question 16 on page 85. So I'll do that at the end. I'll do them in this order, so if you're happy with any of them, just skip up ahead on the video. First one on page 66, I've been asked to look at question 6, which said, let's find it here, 2x squared minus 12x plus 7, express that in the form a times x minus b squared plus c, so in completed square form. So to do that, you're going to take your 2 out as a factor, so that's going to become 2 times x squared minus 6x plus 7. Okay, and then you're going to say, well, to complete the square, half of this number squared is 9. So I'm going to plus 9 and a minus 9 in there. And I get myself 2 times x squared minus 6x plus 9 is a perfect square. It's x minus 3 squared minus 9 plus 7. And the whole thing comes out then as 2 times x minus 3 squared minus 18 plus 7, which is 2 times x minus 3 squared minus 11. Okay, there's question 6. On page 87, question 6, again, gives us the formula for the standard error of proportion and says use the quadratic formula to find p, the proportion, in terms of sigma and n. So our formula is sigma equals root p times 1 plus p over n, and we want to get p by itself, as it were. So multiplying across by n, we'll get n sigma is root p plus p squared. I'm just going to expand that bracket because this is going to be a quadratic in p in just a second. When I square both sides here, n squared sigma squared is p plus p squared, and as a quadratic, that's p squared plus p minus n squared sigma squared equals 0. So they want us to solve that to get a value for p, and that's going to be when p is minus 1 plus or minus the square root of, that's your b, 1 squared minus 4, a is 1, c is minus n squared sigma squared, all over twice a, which is twice 1. That's minus 1 plus or minus the square root of 1 plus 4n squared sigma squared over 2. Okay, those are your two values for p. Find the proportion in terms of n and sigma. So there it is there. Question 7 on the same page gives us this table here. Complete the table by stating whether each quantity is positive or negative, and they filled out two of the things for us. Okay, so if k is a negative number, obviously k is negative. 4k will be negative. If k is positive and greater than a quarter, then it's definitely positive. If it's greater than a quarter, k is positive, etc. Okay, so let's fill that out and then use the table to find the range of values. So we'll do that part afterwards. So when k is negative, okay, that says k is negative, so k is negative. 4 times a negative number is still a negative number. 4k is a negative number, and if you take away 1, you still have a negative number. So this is the only one here. When k is negative and less than 0, that's a negative number, k. 4k minus 1 is a negative, so it's a negative multiplied by a negative gives us a positive answer. Up here, if k is between 1 and 4, or sorry, 1 and a quarter, then it's positive. 4k will also be positive when k is between 1 and a quarter. 4k minus 1, so the biggest value 4k can have in this circumstance is 1. So that means 4k minus 1, the biggest value you can have, is 0. And in all other circumstances, sorry, it'll be 0 when k is equal to a quarter. But our graph tells us k is less than a quarter. So 4k minus 1 will also be less than a quarter. Sorry, will be less than 1. So this will not be big enough to make the whole number positive. That's going to be negative in all circumstances. And then what we have here is a positive number, k, multiplied by a negative number, 4k minus 1, which is going to give us a negative answer. When k is greater than a quarter, k is positive, 4k is positive, 4k minus 1. So 4k, when k is greater than a quarter, 4k is greater than 1. So taking 1 away from it, you still have a positive answer. And here, that's a positive number times a positive number. So you're going to get a positive answer. Second part of that question asks us, find the range of values of k, so the quadratic expression x squared plus 4k plus k is positive for all values of x using the table. Okay, so basically, if that's to be positive, we need to complete the square on it. Okay, so let's have a look for all values of x. So we need x squared plus 4k x plus k. We want that to be positive. So let's complete the square. Half of that is 2k squared is plus 4k squared minus 4k squared. Okay, half of this number squared is 4k squared. So that means this can be written as x plus 2k squared plus k minus 4k squared. And in order for this to be positive, that's what we want. We need this to be positive at all times. That bit there is already positive, so we need k minus 4k squared to be positive. Okay, which is quite similar to this last thing here, isn't it? That's 4k squared minus k. Okay, so k times, excuse me, I'm going to run out of space here. That's going to become k times 1 minus 4k squared. Nope, not squared. Okay, we need that to be positive. Now, that is the negative of this number. Okay, so an equivalent statement is to say that we need k times 4k minus 1 to be negative. Okay, so I've multiplied through by minus 1 and I've switched my inequality signs. And that's negative only in this circumstance, where k is between 0 and a quarter. Now we'll see later on, so there's your answer. We'll see later on another method for doing this, and I think question 14 more or less requires a method we haven't seen in this chapter, which the book does from time to time, and I'm sorry about that. That's question 7. So question 8, I've started here. A, B, and C are positive constants, and the roots of this quadratic and this quadratic are all real and unequal. Okay, that means your b squared minus 4ac has to be greater than 0. Show that the roots of this are not real, that for this one b squared minus 4ac is less than 0. Okay, so we've got ax squared plus 2bx plus c, okay, where the roots are given by minus b plus or minus the square root of b squared minus 4ac all over 2a. But this is the bit we're really interested in, the discriminant. We've got this one. Okay, there's your roots for the second equation. Now we know that this is positive, the discriminant, and we know that this is positive as well. Okay, because we're told that these have real and unequal roots. Show that the roots of this function are not real. So show the discriminant for this one, b squared minus 4ac, show that that is a negative number. Well, we know already from here that 4b squared minus 4ac is positive. Okay, which means b squared, minus AC is positive, and means b squared is greater than AC. Okay, and I know from this one I took a minute before the video to do it, so I know where that's going, that we'll need A by itself, so I'm just going to do that now. That A is the smaller number than b squared over C, excuse me. Over here we also know that 4c squared, this is from here, minus 4ba is a positive number, which means c squared minus ba is positive. C squared is greater than ba, and as I said before, I know that I'm going to want an expression for a, so I'm just going to write that now. A is a smaller number than c squared over b. So looking at what they've asked us to look at, this one, okay, the discriminant 2a squared minus 4bc, we need to show is less than 0, okay? Well, 4a squared minus 4bc is our discriminant. And showing that's less than 0, we can take a factor, because if a squared minus bc is less than 0, then multiplying it by 4 will still be less than 0. So we want to show is that less than 0, question mark. So what I'm going to do here is I'm going to use this expression for a and this expression for a. I'm going to say a squared minus bc. If I replace a, so that's a times a minus bc. If I replace a with a bigger number, and if I replace a here with a bigger number as well, so a bigger number being b squared over c, which is bigger than a, then I'm going to get an answer that's bigger. So something that is bigger than this is b squared over c for the first a. This is a funny little trick. It took me a little while to spot this even, so don't feel bad if you found it hard. The other expression for a is c squared over b minus bc. Okay, so our discriminant is less than this number here, whatever that might be. Okay, well, an equivalent statement for that, if we cancel b's and cancel c's, is bc minus bc, which is 0. So we ultimately get that a squared minus bc is less than, following that logic along, is less than 0, which means 4a squared minus 4bc is also less than 0. So the roots of this function up here are not real. Okay, that was definitely a tricky one. Next one, question 9 on the same page. Given the function minus x squared plus 5x plus 3, that's this n-shaped function here, and g of x is x squared plus 5x minus 1, that blue u-shaped function, find the coordinates of the points a and b where they cross, leaving your answer in third form. So to find the point of intersection of any two curves, you let them equal each other. So for question 9, to start off, you're going to say, well, we need f of x to equal g of x, and that will find us the x values of where they cross. So our f of x is minus x squared plus 5x plus 3 has to equal x squared plus 5x minus 1. Okay, so this is a quadratic equation. If I move everything over to the right hand side, I'm going to get 0 equals 2x squared plus x squared, 5x take away 5x is 0, and then minus 1 take away 3 is minus 4. Okay, which is, we don't even need to go to minus b, that'll say 2x squared has to equal 4, x squared has to equal 2, and x is plus or minus the square root of 2. So those are my two x coordinates. They've asked for the full point, so you need a y coordinate as well. Doesn't matter if you work with f of x or g of x. I'm going to work with g of x, which is x squared plus 5x minus 1. So g of root 2 is root 2 squared plus 5 times root 2 minus 1, and that's going to be 2 plus 5 root 2 minus 1, which is 1 plus 5 root 2. So my first coordinate in surd form is root 2, 1 plus 5 root 2. My second coordinate will be when I plug minus root 2, my other solution up here, into the function, and I get minus root 2 squared plus 5 times minus root 2 minus 1. And that's going to be 2 again, minus 5 root 2 minus 1. So that's going to be 1 minus 5 root 2. Okay, so that's minus root 2, 1 minus 5 root 2. Okay, so this one here, positive x value, positive y value is A. And this one here with a negative x value, negative y value is B. Okay, I was asked to look at question 14, which is definitely a tricky one. So if x is real, find the set of possible values of that function. Okay, so the set of possible values, the set of values for y, if x squared over x plus 1. Okay, well, if you multiply this out, cross multiply, you'll get x plus 1 times y equals x squared. Xy plus y equals x squared. And then if you move everything over, you get 0 is x squared minus xy plus y. Okay, so what you have here is a quadratic equation. You know x is real, that is the roots are real, so b squared minus 4ac has to be positive. Which for us means minus y minus 4 times 1 times y has to be positive. Sorry, minus y squared. Okay, so carrying that on up here, we'll get ourselves y squared minus 4y is a positive number. Now, to solve this, I mean, you can factorize it. Yeah, so the usual way you'd solve this is graphically. Okay, you'd plot it out. You'd say that has factors of y and y minus 4. So it has roots, that's a U-shaped quadratic. It has roots at 0 and at 4. Okay, so the correct answer here then is that y will be positive. That this function, y squared minus 4y, will be positive when y is less than 0, or here. Okay, this is, confusingly, that's a y-axis now, because that's a function in y. When y is greater than 4. Okay, and you haven't seen that trick before. So the other method you might use to solve this, if y squared minus 4y has to be greater than 0, would be to say, well, I know it has roots y times y minus 4 greater than 0. So if y is, you kind of, nearly by feel, you'll say if y is 0 or less, well then this is negative and this will be negative. So you'd say when y is less than 0 is one set of solutions. And then the other set of solutions for this to be positive is for both of these numbers to be positive. Well, the condition there is that y has to be greater than 4 for y minus 4 to be positive. Okay, and if y is greater than 4, this is positive and this is positive. So either both numbers are negative when y is less than 0, that's negative and that's negative, or both numbers are positive when y is greater than 4. So there's question 14, and then I was asked just before I started making the video, I got an email asking me to go to page 85 and do question 16. So page 85, question 16. This one here that we're looking at in class today. The radius is a spherical container of radius, the contents of a spherical container of radius 3 centimeters completely fill a cube of side x centimeters. If the volume of a sphere is given by the formula 4/3 pi x cubed, which is around 4/3 pi is 4.19 times x, the radius cubed. Using the cubic graph, find an approximate value for x, the length of the side of the cube. Okay, so they've given you a volume function. That's how, as the length goes, when it's 3 centimeters, the volume is there, what, it's 30 odd centimeters cubed. When it's 4 centimeters, the volume is 60 odd centimeters cubed, and so on. That's for the cube. This is for the sphere. Find an approximate value for x, the length of the side of the cube. Okay, so you've taken a sphere of radius 3, so you've got a volume there of about 120. The equivalent volume in a cube, if you come over here to the green curve and just drop down, the equivalent volume is about 4.8. Now, algebraically, that same problem will look like this. 4.19 times 3 cubed needs to be the same as a cube of side x, which is going to have volume x cubed. Okay, x by length by width by height for a cube. So, excuse me, 4.19 times 3 cubed is 113.13. So x is the cubed root of 113.13. So that's the cubed root of my answer, 4.83. Okay, so that's the algebraic approach, which gives you maybe a more accurate approach than the graph, but they both gave 4.8 centimeters. Second part, at what approximate value of x would the volume of a sphere be 150 centimeters cubed greater than the volume of the cube, given that the broken line represents v minus 150. So the broken line is this blue curve shifted downwards 150 centimeters cubed on the y-axis. So it's where they cross then, it's where the blue line. But if you look there, at that point your gap between the green and the blue line is about between 50 and 200. It's about 150 centimeters cubed. So it happens here at x equals about 3.5. So the value of x there is 3.5. Algebraically, what you're saying there is the volume of your cube, 4.19 x cubed, minus 150 is the same as the volume of your sphere, x cubed. Okay, so the volume of the cube and the volume of the sphere is 150 and the difference between them. So if you move your x cubed across, you get 3.19 x cubed minus 150 equals 0. Move the 150 across, you get 3.19 x cubed equals 150. And x cubed then is 150 divided by 3.19. So x cubed is 150 divided by 3.19, 47.02. And x then is the cube root of that. Cube root of, my answer is 3.6. Okay, there's the work. Hope you found it helpful, and best of luck in the test tomorrow.